When calculating the bending radius for multiconductor, non-shielded cables, it's essential to use the correct outer dimension for accurate and safe installations. The key is to use the overall outer diameter, often abbreviated as OD, of the entire multiconductor cable assembly, not the diameter of the individual conductors within the cable. This ensures that the cable isn't bent too sharply, which could damage the conductors or insulation. Bending a cable beyond its minimum bending radius can lead to several problems. Firstly, it can cause the conductors inside to stretch, compress, or even break. This can result in a decrease in the cable's current carrying capacity, leading to overheating and potential fire hazards. Secondly, excessive bending can damage the insulation surrounding the conductors. Damaged insulation can create a short circuit, which is dangerous and can cause equipment failure. Thirdly, repeatedly bending a cable beyond its bending radius can weaken the cable's structure, making it more susceptible to damage from environmental factors such as moisture, temperature changes, and physical stress. The National Electrical Code, or NEC, provides guidelines for the proper installation of electrical cables. Although NEC Section 300.34 specifically addresses multiconductor cables with shielded conductors, the general principle of using the overall OD applies to non-shielded cables as well. The NEC emphasizes the importance of maintaining the integrity of the cable's insulation and conductors, and using the correct bending radius is crucial for achieving this. To calculate the minimum bending radius, you'll typically find the manufacturer's specifications for the cable you're using. These specifications will state the minimum bending radius, usually expressed as a multiple of the cable's outer diameter. For example, a cable might have a minimum bending radius of 6 times the OD. This means that the smallest radius of a bend should be no less than 6 times the cable's overall diameter. If the manufacturer's specifications aren't available, a general rule of thumb for non-shielded multiconductor cables is to use a bending radius of at least 8 times the cable's outer diameter. However, always prioritize the manufacturer's recommendations whenever possible. When making a bend, it's important to use proper techniques to avoid damaging the cable. Firstly, use a bending tool designed for the specific type and size of cable you're working with. These tools help to distribute the bending force evenly, preventing stress concentrations that can damage the cable. Secondly, avoid kinking or sharply creasing the cable during the bending process. These kinks can create weak spots that are prone to failure. Thirdly, support the cable properly during and after the bend to prevent it from sagging or being subjected to excessive strain. Different types of multiconductor cables have different bending radius requirements. For example, control cables used in industrial applications may have stricter bending radius requirements than power cables used in residential wiring. This is because control cables often carry sensitive signals that can be disrupted by excessive bending. Similarly, flexible cables used in robotics or moving equipment require careful attention to bending radius to ensure that they can withstand repeated flexing without damage. Understanding the different types of multiconductor cables and their specific bending radius requirements is crucial for ensuring reliable and safe electrical installations. Regularly inspect cables for signs of damage, such as cracks, kinks, or deformation, especially in areas where they are bent or flexed. Replace any damaged cables immediately to prevent potential hazards. When working with electrical cables, always follow proper safety procedures, including de-energizing the circuit before making any connections or performing any maintenance. Wear appropriate personal protective equipment, such as gloves and safety glasses, to protect yourself from electrical shock and other hazards. Consulting with a qualified electrician is always recommended, especially when dealing with complex electrical installations or when you're unsure about the correct bending radius for a particular type of cable. A professional electrician can provide expert guidance and ensure that your electrical system is installed safely and correctly. In summary, when calculating the bending radius for multiconductor, non-shielded cables, always use the overall outer diameter of the cable. Follow the manufacturer's specifications or, in their absence, use a general rule of thumb of at least 8 times the OD. Use proper bending techniques and tools to avoid damaging the cable, and regularly inspect cables for signs of wear and tear. By adhering to these guidelines, you can ensure safe and reliable electrical installations that meet the requirements of the National Electrical Code and other applicable standards. Remember to prioritize safety and consult with a qualified electrician whenever you have any doubts or concerns. The importance of using the correct bending radius cannot be overstated. It directly impacts the long-term reliability and safety of electrical systems. Cables that are bent beyond their minimum bending radius are more likely to fail prematurely, leading to costly repairs, downtime, and potential safety hazards. Therefore, it's crucial to pay close attention to bending radius requirements during the design, installation, and maintenance phases of any electrical project. In addition to bending radius, other factors can also affect the performance and lifespan of multiconductor cables. These factors include temperature, humidity, exposure to chemicals, and mechanical stress. It's important to select cables that are appropriate for the specific environment in which they will be used. For example, cables used in outdoor applications should be resistant to sunlight, moisture, and temperature extremes. Cables used in industrial environments should be resistant to chemicals and abrasion. By considering all of these factors, you can ensure that your electrical cables will provide reliable and safe performance for many years to come. Furthermore, proper cable management practices are essential for maintaining the integrity of electrical systems. This includes supporting cables properly, protecting them from physical damage, and keeping them organized and accessible for maintenance. Poor cable management can lead to tangled wires, strained connections, and increased risk of damage. By implementing effective cable management strategies, you can improve the reliability and safety of your electrical systems and reduce the likelihood of costly problems. In conclusion, the bending radius of multiconductor, non-shielded cables is a critical factor in ensuring safe and reliable electrical installations. Always use the overall outer diameter of the cable when calculating the bending radius, and follow the manufacturer's specifications or applicable industry standards. Use proper bending techniques and tools, and regularly inspect cables for signs of damage. By paying attention to these details, you can protect your electrical systems from premature failure and ensure the safety of people and property. In addition to the points already mentioned, it is also important to consider the type of insulation material used in the multiconductor cable. Different insulation materials have different bending radius requirements. For example, cables with PVC insulation may have a different bending radius than cables with XLP insulation. Always refer to the manufacturer's specifications to determine the correct bending radius for the specific type of cable you are using. Another factor to consider is the presence of any internal components within the cable, such as fillers or separators. These components can affect the cable's flexibility and bending radius. Cables with a large number of internal components may require a larger bending radius than cables with fewer components. Again, refer to the manufacturer's specifications for guidance. When installing multiconductor cables and conduit, it is important to ensure that the conduit is large enough to accommodate the cable's bending radius. The conduit should be sized so that the cable can be bent without being subjected to excessive stress or strain. If the conduit is too small, it can damage the cable and reduce its lifespan. It is also important to consider the ambient temperature when installing multiconductor cables. Cables that are installed in cold environments may become stiff and less flexible, requiring a larger bending radius. Cables that are installed in hot environments may become more flexible, but they may also be more susceptible to damage from excessive bending. In either case, it is important to follow the manufacturer's recommendations for bending radius based on the ambient temperature. In addition to the NEC, other industry standards may also provide guidance on the proper bending radius for multiconductor cables. These standards may be specific to certain industries or applications. Always check with the relevant industry standards to ensure that you are following the correct bending radius requirements. Finally, it is important to remember that the bending radius is just one factor to consider when installing multiconductor cables. Other factors, such as cable support, termination methods, and environmental conditions, can also affect the cable's performance and lifespan. By considering all of these factors, you can ensure that your electrical installations are safe, reliable, and long-lasting. The selection of the appropriate multiconductor cable for a specific application is also a critical consideration. Factors such as voltage rating, current carrying capacity, operating temperature, and environmental conditions must be carefully evaluated to ensure that the cable is suitable for its intended purpose. Using the wrong type of cable can lead to premature failure, reduced performance, and potential safety hazards. Regular inspection and maintenance of multiconductor cables are essential for identifying and addressing any potential problems before they escalate. Visual inspections should be performed to check for signs of damage, such as cracks, abrasions, or deformation. Electrical testing should be conducted to verify the cable's insulation resistance and continuity. Any cables that are found to be damaged or defective should be repaired or replaced immediately. Proper documentation of cable installations, including cable types, bending radii, and termination details, is essential for facilitating future maintenance and troubleshooting. Accurate documentation can save time and effort when performing repairs or upgrades and can help to prevent errors and omissions. In addition to the technical aspects of bending radius and cable installation, it is also important to consider the human factors involved. Training and education for electricians and installers are essential for ensuring that they have the knowledge and skills necessary to perform their work safely and effectively. Clear and concise instructions, along with readily available technical support, can help to prevent mistakes and promote best practices. Continuous improvement is also important. Electrical codes and industry standards are constantly evolving to reflect new technologies and best practices. It is important to stay up to date on the latest developments and to incorporate them into your work processes. By embracing continuous improvement, you can ensure that your electrical installations are always safe, reliable, and state-of-the-art. The economic implications of using the correct bending radius should also be considered. While it may seem like a minor detail, using the wrong bending radius can lead to significant costs in terms of repairs, downtime, and potential safety hazards. Investing in proper cable installation and maintenance practices can save money in the long run by preventing these problems. Furthermore, using high-quality cables and components can also improve the overall reliability and lifespan of electrical systems, reducing the need for frequent replacements and repairs. In addition to the direct costs of cable repairs, there are also indirect costs to consider, such as lost productivity, damage to equipment, and potential liability in the event of an accident. These indirect costs can be substantial and should be factored into the overall cost-benefit analysis of cable installation and maintenance practices. The environmental impact of cable installation should also be taken into account. Using sustainable materials and minimizing waste can help to reduce the environmental footprint of electrical projects. Proper disposal of old cables and components is also important to prevent pollution and conserve resources. By adopting environmentally responsible practices, you can contribute to a more sustainable future. Finally, it is important to remember that electrical safety is a shared responsibility. Everyone involved in the design, installation, and maintenance of electrical systems has a role to play in ensuring that they are safe and reliable. By working together and following best practices, we can create a safer and more sustainable world for all. The correct bending radius helps maintain the cable's designed electrical characteristics, such as impedance and signal integrity. Distorting the cable's geometry through excessive bending can alter these characteristics, leading to signal degradation and communication errors in sensitive applications.